Okay, hopefully you did pretty well with the sine function, because now here's a little video on the cosine function. Now, we talked about before that the cosine is, when you look at the unit circle, the cosine is always going to be the x value. So when we're looking at 0 degrees, which is right down here like this, got to put my little degree signs, but we're looking at 0 degrees, we look over here, the cosine of 0 degrees is 1. So that point, instead of being 0, 0 like the sine function, that point is 0, 1. So it goes up 1. Now, we also know that this is also 360. So at 360, and this is a periodic function, which means that it keeps repeating itself as it goes around the circle, they're going to always be the same. So then at 90 degrees, our cosine, which is our x value, is 0. So that point at 90 degrees, if we go to graph it, is going to be over to 90 and 0. Then at 180, when we look at 180, our cosine of 180 is going to be negative 1. So that little point is going to be 180, and at 180 we go down to negative 1. Then at 270 we go back to 0. So at 270 my point is 270 and then 0. And then we've got our 360. So this right here is the parent function, and we've talked a ton about parent functions. This is the parent function for the cosine. So all of the cosines, oops, I forgot to put this little guy, all of our cosines are going to look the same. And they kind of look like, if you look at them, they kind of look like a pulled out parabola. But notice, I did not put any arrows on the ends because this is just called a period of a cosine function, because if I continued it in either direction, it would continue to do the exact same thing. So we stop it right here and we do not put arrows, because if we put arrows, it would make it look like it kept going this way. But what's going to happen as it goes around the unit circle is it's going to keep repeating itself. That's why it's called a periodic function, okay, because it keeps doing the same thing. None of ours have done this before. All right, so we are going to look at some of our transformations. This is, again, our parent function. And if we put a 2 in front of this, very similar to what we did with our cosine, or our sine, if we put a 2 in front of it, then all of these y values are going to be multiplied by 2, just like our sine. So instead of going up 1 right here, if that has a 2 in front of it, we're going to go up 2. And if it starts at 2, guess where it's going to end on 360? It's going to be the same thing, because that right there is the same point on our circle. Then at 0, 0 times 2 is still going to be 0. And then down here at 180, negative 1 times 2 is going to give me negative 2. This one goes back to 0. And again, we're back to 360, which is exactly the same thing as 0. Then if we choose to graph a different one, which would be maybe like have a negative in front of it, do you think you know what would happen to a negative? We would take all of these and we would multiply them by a negative 2. Now, it's not moving up or down, even though it's starting at 1 and it looks like it moved up 1. It's different than the sine function. The sine function did start at 0, 0, but the cosine function, it starts at 0, 1, okay, the parent function. So when we start to do this one, it would normally, our parent function is at 1, but we would multiply it by negative 2, so it's going to be a vertical reflection. If this is negative 2, this is also going to be negative 2. And what you can kind of start thinking too is, smack dab in the middle, it's going to do the opposite. So what used to go down is now going to go up, and the zeros are going to stay exactly the same. So you kind of start seeing little patterns, which should make it a little easier to graph. God, that one spot in the board, I guess I'm doing this at home, so I guess this is not my smart board. It is actually my tablet. So that would be the graph. This would be a vertical stretch. Ooh, ooh. And this would be a vertical stretch and reflection. Notice too that we can also have a vertical shrink. And if we did have a vertical shrink, I'm going to make him yellow. If we did have a vertical shrink, it would be 1/2 cosine theta. So instead of all of these being multiplied by 2, all of this would be multiplied by 1/2. So if all of it was multiplied by 1/2, the zeros would not change, but all of these ones and negative ones, they would be half of that. So if I went to graph this one, instead of going up 1, it would go up 1/2, and that would be a vertical shrink or a vertical compression. The zeros are still going to stay the same. They never change. And if this is at -1, at 360, it's also going to be -1. So in the middle, if it normally goes to -1, it would go to -1/2. So since he's yellow, hopefully you can, I don't know if he stands out or not, but you can kind of see him, and that's a vertical shrink. So all of these are very, very similar to the sine, except for it is the cosine. So I'm going to possibly not do quite as many examples, but if we had the cosine of theta -2, what that does to the whole graph is it moves it down 2. So just like with my sine function, I usually just go ahead and draw a new asymptote because it's kind of hard, because when you start graphing it, when you say that something is 0, you want to go back to the x-axis, but you really can't because you have to go back to the new x-axis. So what you do is it doesn't go left or right, so you start right here. That's your new origin, and from your new origin, you go up 1. And at 360, of course, it's going to be the same thing. What's going to happen smack dab in the middle is it's going to go down because that's my 180. Then at 90 degrees, it's at 0, and at 270, it's 0. So just like all of the other graphs that you've gotten to be like perfect at, you'll get to be perfect at this one too. So we're going to move on because, of course, if it had a +2, then you would move the whole thing up 2, and you do pretty much the exact same thing. So, and again, I can't record too long because I can only post things if they are less than 15 minutes. So that's why I'm kind of hurrying. Blah, blah, blah. So let's just say we have the cosine of theta plus 90 degrees. So if we had that, that basically means that we're going to move left 90 degrees. We're not going up or down, so my new point is going to be 90 degrees. And I'm not moving up, so that's like my new origin. But keep in mind, it doesn't stay at 0, 0. It is up 1. And since we moved 2 spots over from where it normally starts, if at 360, we're going to move over 2. Now this is where we can start trying to make it a little easier, because this is 8 blocks long, just like our sine function. So if we go in the middle, 1, 2, 3, 4, what happens in the middle is it goes down 1. So if this is our origin, or this is our x-axis because it didn't move up or down, it's going to go down 1. And then in between the other two, it just goes back to 0. So this is going to be my cosine function with a shift left 90, because we always do the opposite, which makes that -90. Now we've talked about all the different shifts. So on this one, we're going to put a little bit of everything. So if we put a little bit of everything on this one, let's put what should we put? Let's do a 1/2. 1/2 cosine of theta plus 40, no, let's not do plus, we just did plus. And sometimes it might actually go off the page just a little bit. So it's 1/2 cosine of theta minus 45 degrees. And then let's do plus 3. There we go. So if we want to do this one, we want to start graphing this one, what we're going to do is, I want to keep in blue. What we want to do is we want to figure out where we're going to start. So if this is theta minus 45 degrees, we want to start at positive 45 degrees and at positive 3. So if we want to do that, that's going to be right there. All right, that's going to be the spot of my new x and y axis. And I usually just draw this one because the y is a little bit easier to keep track of. So normally when I go to graph it, I normally, at this little spot, I go up 1. But since that is a 1/2, that is a vertical compression, vertical shrink, I'm going to go up a half. Now, 8 spots over, because remember this is 8 blocks long, we're going to do the same thing because that's our revolution around the circle. So 1, 2, 3, 4, 5, 6, 7, and it's going to be 1 over here, which is fine. I'm going to try to keep most of them very, very close, but it's okay if it goes over there. So halfway between, and it doesn't matter now that it's not 180 degrees, halfway between 1, 2, 3, 4, is that it? 1, 2, 3, 4, it's going to go down a half. In between the other two, it's going to go to 0. So you can tell that's what the graph looks like. So that's one that's gotten all the shifts. Now, if you did not fill in all of your graphs, that's fine because I know how many that I put on here, but I do not want to have to do this again. So I'm going to stop at that, and hopefully I did not go past 10 minutes. So anyway, hopefully this works, and we will be graphing harder ones that have horizontal stretches and shrinks like we did all the other graphs a little bit later.